Welcome to Axioms of Probability. This is part of a Applied Bayesian Statistics course at Virginia Commonwealth University. All right, so what we've done so far is we talked about a sample space, an event, a complement, an intersection, a union, an empty set, and we've defined what a Venn diagram is. So these basic ideas here we're going to put together to define probability. Okay, we're going to actually define it, which is very different than what people think. They just think that it's just some rules that are put together. But it's actually based on 3 axioms, and these are fundamental assumptions. As long as we have these 3 fundamental assumptions, we can build all of probability just from these 3 concepts, which is pretty amazing if you think about it. You only need 3 ideas, and bingo, you can get all of probability from it. All right, the first axiom is the probability of the sample space is equal to 1. Okay, well, what does that mean? Well, it has several meanings. So it means the sample space is complete. Everything that can happen is in there. There's nothing that could happen that we didn't account for. It also says if the experiment is conducted, an outcome will happen. Okay, the outcomes in the experiment are clearly definable so that we can actually assign every single one of them a probability which will total up to 1. All right, the second axiom of probability is the probability of any event is greater than or equal to 0 for all the events in the sample space. So we're saying we can't have negative probabilities, and it also says that all events are assigned a probability, okay, even if that probability happens to be 0. Everything gets assigned a probability, and they're all greater than or equal to 0. Okay, now this is the one that usually confuses people, but it's not that hard of an idea. It just takes a moment to think about it. Suppose E1, E2, E3, ... There's a lot of these. Are all events in S such that E sub I intersect E sub j is equal to the empty set, which means they don't overlap. Remember our picture before when we had the Venn diagram that had 2 sets that didn't overlap? That's this. None of them overlap, okay, such that I is not equal to j. Then, if we wanted to union these things together, we wanted to find the probability of all of them combined together, well, that says we can just add up each one of their probabilities individually. Since they don't overlap anywhere, they should be easily added up. And basically what this says is, even though it seems weird, probability behaves like area. Okay, if you were to find the area of a region that's weird, you'd probably chop it up into regions that you know how to find the area of, find the area of each one of those, and then add it back up. And that's essentially what that's saying here. Now, keep this idea of area in your mind, even though we'll kind of wander away from it for a bit. We'll come back to it, and it will be very, very important. All right, so here's our axioms. So sample space is equal to 1. Probability of any event is greater than or equal to 0. And we have this sort of union additivity thing going on here. Now, notice that nowhere in here does it say the sum of any probabilities is equal to 1. We'll talk about that later, but it's not an axiom. These are the only 3 concepts we need to define probability. Not just understand it, but to define it, what it actually is. So here's a formal definition, and we're going to keep using this as we go forward, so you'll see me bounce back to it again and again and again. All right, so we're going to move on to the next video, so see you there.